In this lesson, we're going to be solving this problem. This problem is under angular motion. The problem reads as follows. A bicycle wheel of a diameter 0.6 meter accelerate from 2 revolutions per second to 25 revolutions per second during 4 seconds. Calculate angular acceleration, average angular acceleration speed of a bicycle after 4 seconds, linear acceleration, angular displacement during 4 seconds, distance covered by bicycle during 4 seconds. Here, this statement, I think it made a mistake here. Diameter. One must be out. So here we are given the diameter. The diameter, it is 0.6. The diameter is 0.6 meter. Then we are given the rotational speed, which is n1. Here it's n1. Here it is 2 revolutions per second. Then we are given n2. Here it is n2 is equal to 25 revolutions per second. What else we are given? Then the time, it is 4 seconds. Then here, before we calculate, let us calculate each angular velocity. Let us calculate the angular velocity 1 here, angular velocity 2. Then how to calculate it? We will say angular velocity 1 is equal to 2 pi. Then here we will say 2 pi. Then we put that 2, this 2, it is 2. Then this will give 12 radi per second. Then angular velocity 2, it is 2 pi. Then you put n2, this one here, it's gonna be 2 pi. Then you put that 25 instead of n2. Then you get 157.1 radi per second. That is our angular velocity 1, angular velocity 2. Now let us calculate the acceleration. The formula to calculate acceleration, it is angular velocity 2 minus angular velocity 1 divided by time. Then here, angular velocity 2, it is here. Got it? It is this one, 157.1 minus angular velocity 1. Here it is, got it here. It is 12 divided by a time. Time is 4. Here it is. Then here we get our angular acceleration to be 36.3 radi per second squared. That is a angular acceleration. Now let us calculate this, which is average angular velocity. To calculate the average angular velocity, we only say angular velocity say equal to angular velocity 1 plus angular velocity 2 divided by 2. That's how you calculate the average. Then here, angular velocity 1, there it is 12. Angular velocity 2, there it is 157.1 divided by 2. This will give average angular velocity to be 84.54 radi per second. That is our average angular velocity. Now the statement say, let's calculate them. The speed of the bicycle after 4 seconds. After 4 seconds. That means here we will only use angular velocity 2. Will not use angular velocity 1 because they said after 4 seconds. Then let us calculate now. This here they say the speed. That means they are looking for the linear speed. So we have to introduce the formula which combine the two properties. The formula which combine the two properties, it is nothing but it is V is equal to the angular velocity times the radius. This formula, it combines the angular part and also the linear velocity, because here they are looking for the speed. That means they are looking for the linear velocity. So that's how we calculate it. We introduce this formula which combine these two properties, the linear one and the angular one. Here these are, let us write here, this r, it is nothing but we will just say r is equal to the diameter divided by 2. The diameter is 0.6 meters, then you divide by 2, you get this r, which is the radius of the circle, which is 0.3 meter, like here. Then you take it here to substitute on this formula. This is a linear property, this is an angular property. So it combines the two. Here we're looking for a speed. So the angular velocity after 4 seconds will take this angular velocity 2, not 1, because they say after 4 seconds. Then we'll say 157.1. Then we times by this radius, it is 0.3. Then we get the answer to be 47.13 meters per second. That is the speed after 4 seconds. Now what they are looking for now, they are looking for the linear acceleration. That means we will still use the formula which combine the two properties. We're looking for the linear acceleration. That means we will say linear acceleration is equal to then the angular acceleration and also the radius of bicycle wheel. That's the radius of a bicycle wheel. Here, then here our radius, here it is. Then the angular acceleration, now we will take this one that we calculate here on the first. Here we take this angular acceleration, because now they didn't specify that the linear acceleration after 4 seconds. They didn't specify. They said the linear acceleration. That means we'll take this one. The linear, it will take this one for the angular acceleration. Then here it says 36.3. Then you put this one 0.3 like this. The answer that you get here, it is 10.839 then meters per second squared. That is the linear acceleration. Now we are required to find the angular displacement during 4 seconds. Then here to find the angular displacement, formula to find the angular displacement, it is these symbols for angular displacement. Then the formula, it is angular velocity 1 plus angular velocity 2 divided by 2. All this put on, then we times by the time like this. Since you see that on the bracket, this portion, all this portion, it is the average angular velocity. So we've got the average angular velocity. It was 84.54 rad per second. It was like this. So without wasting time to calculate this, because we have already calculated, then let us put this 84.54 like this, then put the time 4 seconds. Here it gives us the 338.16 radi. It's like this. Give 338.16 rad. Now the last part says calculate the distance covered by the bicycle during 4 seconds. That means also we're gonna use the formula which combines these two properties. Then the formula which combine these two properties, it is S for the linear displacement is equal to then the angular displacement times this R. Here, this is the linear displacement. This is the angular part. Then this is the radius of the bicycle's wheel. The radius of a bicycle wheel. Then here we've got just now here it is the angular displacement. It is 338.16 like this. Then you put the radius of a bicycle wheel to be 0.3 like this. Then you get a linear displacement to be 101.4 meters like this. That's what the statement is looking for here.